Today we're going to be looking at exponential problems that involve money. You will see actual formulas that the banks will use to help determine how much interest you are earning. Your objective that you're recording is I will be able to use exponential functions to model and solve real-world problems. Here's the first formula that we're going to work with. This is a standard equation for exponential growth when we're talking about money. So this equation that says A equals P times 1 plus R to the T, that is if we are talking about growth. You will probably remember earlier on in the chapter we also talked about if it was decay, instead of 1 plus R, it was 1 minus R. So this is similar to the exponential growth and decay problems we had. So you will be either using plus R if it's growth or minus R if it is decay. Now, A is the amount of money after so many years have passed. So this is like your balance, your amount of money at the end of a certain amount of time. The P, your principal, that is the amount of money that you put in the bank. That's your starting amount of money. And then the 1 is because we're adding, so it's 1 plus the rate. Now remember, when you go to write the rate, it is always written as a decimal. So if the problem says it's like 3%, you need to change that to the decimal 0.03. And then T stands for time, and T is the time in years. So if the problem says 12 months, you would actually change that to a 1 for years. This is a formula that you do not have to memorize, but you do need to know when to use it. So we only have 2 examples to guide ourselves through today. Here's our first example. Yes, I would like you to write the story in your notes, and then we will have the 3 questions here, as well as graphing. I would like all of this to be in your notes. It says you deposit $3,000 into an account that pays 6% interest compounded yearly. The equation is right here for us. The amount we have is equal to the initial $3,000 principal times 1.06 to the T power. The question is, how much money will we have in the bank after 5 years? Well, we're going to take that equation and we're going to simply sub in the 5 for the T. So in your calculators, you are literally going to type in 3,000 parentheses 1.06, and remember, to get that exponent, you hit the upward caret and then the exponent 5. If you type that directly into the calculator as is, you should be able to get to the final answer in one step. The amount after 5 years would be equal to $4,014.68 if we round to the nearest penny. Now, if you wanted to solve that same problem using order of operations, we can still get to that same answer. Instead of going right to the calculator in case you don't have one available, order of operations says exponents come first. So you would do 1.06 to the 5th power, which is 1.06 times 1.06 times 1.06 times 1.06 times 1.06. If you do that, you get a number that's close to 1.3382. We would then multiply that by the 3,000, and when we do that, we will get back to the same answer of $4,014.68. So no matter how you go about just typing it right in or doing order of operations, you will get to the same answer. Now let's just clean that up. Our final answer was 4,014.68. Now the next question says, how much money would you have in the bank after 20 years? Well, we use our same formula. We're still starting with our initial value of principal of 3,000. It is still 1 plus the rate, 1.06, but now we're doing it for 20 years. So you're going to plug that into your calculator and try and do it all in one step. Were you able to get that your amount would be $9,621.41 if we round to the nearest penny? If not, take a moment, go back, double check, make sure you can get to that value. Now, in order to graph this equation, you are probably going to want to go to your graphing calculator. You're going to want to go to y equals. You're going to type in the equation, the 3,000, and then in parentheses the 1.06, and then you will close your parentheses, and then to tell it to go to the exponent of 5, you'll do that upward arrow, like I call the caret, to the 5th power, and then when you hit enter and graph, you will be able to do second graph to get your values. When you're typing that into the calculator, make sure that the exponent is an x. If you just type in a value in the y equals screen, it's not going to be able to graph anything. It's got to have the x and the y variable in there. So make sure you're typing in 3000, the parentheses 1.06, close parentheses, to the power of, and then put an x in there. You can hit second graph, and now you can get your table of values. While I am looking at that table of values, I can plot my points. We know that our initial or starting value is right here at 3,000. After 1 year, I have 3,180, slightly more. And then after 2 years, I have 3,370, a little bit more. It's going up in small increments at first. And then I'm going to slide over a little bit at 5 years. We're finally just above 4,000. And then if I continue to scroll down on my table of values on my calculator, when we get to 10 years, now we're at about 5,372. So I'm going to slide over on my graph to 10, and now we're going to be at 5,372. So you get the idea that the graph is growing exponentially similar to that. So that will go ahead and give you your graph. Just make sure I wrote the little notes on the bottom. It's up to you if you want to write them down. If you go to y equals and then type that in, second graph for the table, and you can use that to plot your points and to find the function when x is 10. So the question says, about how many years did it take him to have about 5,372? Well, that's right where we were at, right at 10 years. On our table, it says when x is 10, the y value is 5,372.5, which is our 50 cents. So we used our second graph in our table to be able to find that answer. That happens at about 10 years. Once you are good, you have the problem written, the questions, the graph, and the hints on how to graph, you're ready to move on to our second and final example. Yes, your notes are really short today. Now, this is very important that you go ahead and write this problem down and not skip writing the problem. You want to enlarge a picture. On our phone, we just use 2 fingers and we stretch it and it automatically enlarges a picture. But there's actually a function that your calculator or camera or screen or computer is using. In this example, the original picture is starting at 3 inches in length. Every time you push the enlarge button, you are increasing by 7%. Well, the fact that we are increasing means we're going to use the formula that our amount is equal to whatever our initial was, and then 1 plus the rate to the number of times. So very similar to our money one. Our initial or starting dimensions was 3, and then it's 1 plus. Well, the rate, we've got to take that 7%, move the decimal 2 times to the left, and we get 0.07. And then it's to the t power. We don't know how many times we are going to press it. So if we just simplify in parentheses, we would have 3 times 1.07 to the t power. That is the equation that represents how we would find the new dimensions after enlarging it so many times. So the question says, how long will the side be if it's initially 3 and we press the button 5 times? So in your calculator, you would type in the 3, the parentheses 1.07, to the power of 5. Go ahead and do that on your calculators and see how you did. Were you able to punch it in correctly and end up with the new length would be 4.21 inches? If you did, you are good to go. So you need to be able to read the problem and find out if it is increasing or decreasing. If it is increasing, you are using the formula that has the initial or starting amount, and then it's 1 plus the rate. If we're talking about decreasing, the formula is similar. It's 1 minus r to the t for a number of years. So make sure you are paying attention to which formula you are using. Increasing is 1 plus r, decreasing would be 1 minus r. Once you're done with those examples, you are done and you are ready to begin your assignment.